Hi folks, I think I'm live now. I am just setting up, I always have issues with the YouTube stream, so I'm just setting that up so it'll go live my website. Give me just a couple minutes and then I'll get started. If you haven't joined me before as I record, oops, sorry, that is an old video. If you haven't joined me before, I am recording lessons for an upcoming course. It's called, Going Deeper with R. It is on the R for the Rest of Us website. You can check it out there. And just FYI, this is like a very kind of raw version of me recording lessons. You'll see I do a lot of retakes, all that kind of thing. Go back and forth between lessons as I realize things aren't quite flowing the way I want them to. So yeah, just keep that in mind as you're watching. Okay, let me just update the website. All right. Let me check to make sure that worked. Yep, I can see it right there. Awesome. All right. Cool. Okay, let me move to R. So I have, this is all my slides that I've developed within R, within R Markdown, using the Sharingan package. So I have been, last week I was working through a bunch of lessons, did some importing of data, tidying data, reshaping, dealing with missing data, changing variable types, advanced variable creation, advanced summarizing, binding data frames, creating functions, and now we are on to data merging. So let me actually flip through this and get to the right point in my slides. And I'll just put this out there. I mention this every time. If you're watching and have any comments, questions, feedback, please feel free to chat it in whatever location you're viewing this. That can be Twitch, Twitter, YouTube. I'll get access to all of your messages. All right, we did the advanced summarizing. Talked about ungroup. Binding data frames, functions. Okay, oops, there's data merging. So I also have, and I'll just bring it over here for a second. This is a package that I have developed, which is the package as if I were doing this as a student. So I'm just going to run everything that I've done up to this point. So I am prepared when I get to the example section. As I get started, I'd love to hear, I kind of ask this every time, I'd love to hear who you are, who's watching, and where you're watching from. I'm just genuinely curious. All right, let me minimize this. I'm just going to look back at my slides, make sure to orient myself. So I'm talking about data merging. giving an example using this kind of fake German speakers, French speakers. You'll see I'm going to add in French speakers data, and then I'm going to talk about joins generally. I'm making a comment about the fact that I basically always assume, like Klaus Wilke suggests here, I basically always do left joins. So actually teaching this can sometimes be a little challenging for me because I basically only do left joins and then deal with my data after the fact. But I'll do my best to give examples. Hello, Scott in Belfast. Delighted to have you with me. I think it's super cool when people join from such far off places. I'm across the world in Portland, Oregon. Okay, flipping through the various joins. All right. Awesome. And I have these amazing visualizations made by Garrick Aiden Bowie that are such good teaching tools for talking about doing data merging. Cool. Just looking at this. Okay. All right, let me give it a first shot. Probably won't go exactly the way I want the first time, but it's okay. And actually, I just need to flip back real quick here because I need to see, I like to do all my teaching presenting it starting as a problem that people are solving because I don't want it to be just like a series of kind of disconnected steps like in a cookbook. I want people to understand the why behind it. So here, the why, yeah, and it's going to be the same for the student example. The why is, in this case, we have data that just has the district ID, which is a numeric, which isn't super useful. So I'm going to then join my data with another data frame that has district names so that we can talk about that as well. Actually, one second. Oh, you know what? I should just restart this because I was actually just looking at the student example. So my example that I'm using is third grade math proficiency. Math scores, something. Third grade math proficiency 1718 didn't load. Let me make this a little bigger. Last time I made a function to looks like I have something off here. What's off? Unexpected. Super weird because it worked last time. Oh, weird. I have an extra random S there. Okay, now that works. All right, awesome. Okay, cool. Close that. Minimize this. All right, let's give it a shot. The next thing we're going to talk about is data merging. Up to this point, we've been working with a single data frame, but oftentimes what you need to do is actually work with multiple data frames and join them together. And the dplyr package has a whole series of join functions that we're going to use that are really helpful for doing this. I'm going to start out by saying that all of the animations and explanations here come from a project called Tidy Explain by Garrick Aiden Bowie, which is really great. And I use it actually as a reference for myself when I'm going back and trying to think through all the various joins. Let me actually do one thing. I mean, I'm going to edit this, but let me go into full screen real quick. So this is the tidy explain package, and you can see if I scroll down here, you're going to see there are a bunch of, I thought that was an animation. Yeah, there we go. Let me just try that again. So you can see in the tidy explain package, there are a bunch, one more time. So you can see in the tidy explain package, there is a bunch of explanation of various types of joins. So for example, you have mutating joins, which we'll talk about in a second. And there are even these really nice animations that I'll use to demonstrate this. So I will post a link in the Learn More section and definitely take a look at this package. To talk about data merging, let's work with our German speakers 2019 data frame. So let's say we have just states and number. So number of German speakers in 2019. You can see I can scroll through and I've got data for each state in the US. And I can see that there are 51 rows. I think that's because I included the, District of Columbia. Let's say now I read in a data frame that is French speakers 2019. You can see I'm reading it in. Just because I'm OCD, let me do one thing. Let me exit full screen. Whoops, that's not what I wanted to do. I did want to change the indentation because it was off. And I like to have the code just as clean as possible so that when people are looking at it, they can really focus on what's in the code as opposed to the way it's formatted. So yeah, just want to line that up. Gonna knit this again. Just give me a second while this knits. Okay, let me just refresh this. All right, cool. Let's say we also have a French speakers 2019 data frame, and you can see I am reading it in my package that I've created for this course using, again, the readXL function, using the path, and then the sheet, which is French speakers 2019. I can take a look at it, and if I scroll through, you'll see I have state, and then French speakers, which is showing the number of French speakers. I can go next, and you see here, just FYI, because it's going to become important, I only have 9 rows. Okay? Keep that in mind. Let's talk about joins. Joins generally follow this pattern. That is not right. And actually, I am going to use Garrick's I like his image here that just demonstrates that X stands for one data frame, Y stands for another one. So I'm just going to put that in. Okay, let me... and then this should actually be like that. I don't know why I put type of join before the assignment operator. That's obviously not right. Oops. Okay. Scott, if you're still there, I'm actually curious if you currently use R, if you're looking to learn R, what your experience with R is. Anyone else, too, if you're there watching. All right, I'm going to add in this image, images, and it was called original DFs. I'll show that, and then I'll talk about the syntax. All right. Okay. All right. Close. Oops. Close that. Refresh this. Oh, that's way too big. Hold on one second. Try this again. Hello, Emre. Thanks for joining. Curious to know where you're joining from. Yeah, please go ahead and ask, Emre. Looks like it's still too big. All right, cool. So I just need to actually do one thing. I need to make this a new slide. I'll reknit that and I'll take a look. Emery, you're asking about, you're saying how can you build a desktop software with R? Like in other words, to make some kind of software using R? Can you maybe just if you can clarify a little bit, like kind of what you're hoping to do? All right. Just checking that. Okay, that looks good. All right. In other words, you're trying to make some kind of software that relies on R. I will say, Emery, that is an interesting question. It is really far out of my area of expertise, so I'm not sure that I'm going to be able to offer you much, unfortunately. You could definitely use the rstats hashtag, see if other folks might have more ideas than I'm able to offer. Okay. Oops. All right, let me start this again. And Emery, if there are other more specific questions, feel free. I may or may not be able to answer them, but feel free to ask. All right. So I'm going to be at the point where I've talked about the French speakers data frame, and now I'm just talking about joins generally. So in talking about joins in general, we are going to use this notation where X represents our first data frame and Y represents the second data frame. Specifically for our case, X in this case, let me try that again. So from here on out, in thinking about the various join functions, we're going to use this notation. X is going to represent our first data frame, and Y is going to represent the second one. And it's also actually useful to think about them in terms of left and right. Left is going to be X. In this case, you can see it's actually on the left side, and Y is going to be right. In our case, we're going to have X be our German speakers 2019 data frame, and the French speakers 2019 data frame will be our Y. For all of the various joins that you're going to see, it follows this pattern. You put first the function name, which is the type of join, and I'll show you there are various types of joins. Then you put the name of the first data frame, X. In our case, that'll be German speakers 2019, as you'll see. Then you put the name of the second data frame, or the one on the right, which is Y, or in our case, French speakers 2019. And then you have to tell it what variable you want to join on, what variable is shared in common between the two data frames. Now, you don't have to put this, and the function will do its best to guess, but it really is best if you identify the variable to avoid any issues. Now, what if we don't have a single variable that has the same name in both data frames? Well, actually, in putting together the materials for this course, I realized you can do this in this way. So the first line is identical, but you simply say, oh wait, that's not the part that I actually realized was different. Let me go back to here. What if we don't have a variable with the same name in both data frames? In other words, what if we have, say, a variable that is number underscore X in one? No, let me do it slightly differently. Just a second. What if we don't have a variable that has the same name in both data frames? For example, if you recall in our German speakers, no, that's actually not what we want. What if we don't have a variable with the same name in both data frames? For example, what if we're working with US states data, and in one data frame, the variable is called US states, and in another one, it's called USA states. How do we do that? Well, you do it like this. The first line stays the same here, but in the by, we put equals C, and then within C, oh, I am missing a close parentheses there. Gotta fix that. I didn't throw an error because I have it set to not evaluate any of my code chunks by default, because mostly I just want to actually like show examples, but that's going to be a problem. refresh this. Sorry, my computer's just going a little slow. All right, that looks better. Okay. All right, I'm going to start back at the beginning of this slide because I did not have that syntax correct. All right. So for all of the joins, it's going to follow a similar syntax. You're going to use the function, which is the type of join that you want to do. So I've put type of join here. That's obviously not a real function, but I'm using that as an example to demonstrate that's where you will put the name of the function, left join, right join, etc. Then you're going to list the names of your data frames that you want to join. So X being the first one, Y being the second one. And then you need to tell the function what's the variable that the two data frames share in common. And you do that using the by argument. And you give it then the name of the variable that they share in common, the ID variable that I've used just as kind of a generic example here. Now you don't have to put that, and the function will do its best to guess what the variable is that the two data frames share, but it really is best practice to do that to ensure that you get the result that you want. What happens if we don't have a variable with the same name in both data frames? Say, for example, you're working with two data frames that have data on US states and you want to join them. In one, the variable name is US state. In the other one, it's USA state. How do you do that? Well, you do it using this. You do it. Let me just start that again. What if we don't have a variable that has the same name in both data frames? For example, if you're working with data that say deals with US states, and in one data frame, the variable that has the state name is just US state, whereas in another one, it's USA state. How do you deal with that? You do it using this syntax. Type of join again, XY, that's the same. But in the by section, using the by argument, you do by equals C, and then you list the name of the ID variable in the X data frame in the first data frame equals ID variable in the second data frame, so ID variable Y in this case. What if we need to join on multiple variables with different names in both data frames? To do that, you just use this syntax. So the by equals, and then the C, since we're doing multiple elements here, and you just list the variable names and their equivalents in the second data frame. So variable name or ID variable A equals ID variable B, ID variable C equals ID variable D. Okay? One question that comes up is which join should you use? This is a Twitter post from Klaus Wilke, professor at UT Austin, who suggests that you always assume that the left join is the right, as in the correct join, and just deal with it if you realize it's not. And I put this because this actually mirrors my experience 100%. I will teach you all of the joins, but I will say that I almost always use left join, and on the off chance that I can't get that to work, then I deal with it using either a different join or a left join and some other series of functions after that. There are kind of two types of joins. There are what are called mutating joins, which as you can see here in this quote I've taken from R for Data Science, copies variables across from one table, in other words, one data frame to another. Okay? And that's the type we're going to start out with. You know what? I don't want the images to show up right away, because I know as soon as those images show up, that's the only thing people are going to focus on. So I'm going to add just little pauses here before the animations so that I can just talk about the what's going on and have people start to think through it before they actually see it. Okay. Let me knit that. All right. Oops, let me refresh this. I just want to make sure nothing's getting cut off here. Yeah, I think it's good. Oh, that is actually getting cut off just a little bit. Let me try something with this to see if I can get it to fit. So there's a pull left option. So if I did pull left and then pull right, let me try this. So in other words, to show the text on the left side and then the image on the right side. Let me see if that might work. Okay. Refresh this. I think this could work. That's weird. I don't know why. Why is there so much space in the top? Let me just try knitting this again. Unfortunately for me, this is the nature of recording a course, is that I'm quite picky, and so I end up making little changes along the way. All right. Try this again. It might actually be just, hold on, let me inspect this. It might just be taking up that much space. So, how can I make this fit? I guess I'll just put it on a new slide. And refer back to the other slide as necessary. So right join. Full join. Inner join. Semi-join. And anti-join. All right, I'm going to reknit this. So all I'm doing now is just putting this, the animations on their own slide. And I'll just refer back to the text. Okay. Wait, that's not right. Why is it? Just make sure everything fits. Yeah, it looks like that fits. Okay. All right, okay, let me start with this. The first join we're going to use, and again, this is the one I use 90% of the time, is left join. So in this, we're going to take all rows from X, so all of the observations, and all columns from both X and Y, so from the original data frame and the one that we're joining to it. Rows in X that do not have a match in Y will just have NAs in the new columns that are created. Okay, so let's actually look at an animation of what this looks like. You can see X is the one that's on the left here, and then Y is the one that's on the right. You can see they're being joined based on this variable here. And so this observation here, 4, which does not have a match in x, is simply dropped. Okay? We are also, though, keeping all variables. So for example, this variable, which doesn't exist in the original x data frame, now does exist after we do this left join because we're keeping all columns, but we're dropping any rows that do not exist in the x data frame. Yeah, I just had to flip back to make sure I got that right. Okay. Sorry, folks, just one thing I want to do here. Whoops. So I want to actually just show the code first before I show the results. At least just for the first one. I think the other ones, people will kind of get it by that point. I'm not as worried about them seeing the results right away. Okay. All right. Oh, what is going on behind the scenes there? All right. Let's now use our German speakers and French speakers data as an example. We can join these. The variable that they shared in common was state. So I can do left join German speakers 2019, comma French speakers 2019. So X is German speakers, Y is French speakers, and by the variable they share in common is state. When I do that, here's what I get. I've got the state now, and that's got 51 rows because we're keeping all rows, all observations from the X data frame, from the first data frame. In other words, from the German speakers data frame. Recall that the French speakers data frame only had 9 variables. Then we have number, which is how in our original German speakers 2019 data frame, that was the name of that variable. And then we have French speakers here. Now, if I scroll through, you'll notice we only have data for French speakers down through here. Everything past here simply gets an NA because we keep those rows, but when we add this column, they don't have any data, so they just get NA. All right, let me just... Let's talk about right join now. The definition is up here, and that is we take all rows from Y, all columns from X and Y, and rows in Y that do not have a match in X. Let me try that again. Next, we're going to talk about right join. As you might guess, it's kind of the opposite of left join. We're going to keep all rows in Y. We'll keep all columns from both X and Y. And any rows in Y that do not have a match in X will just have NAs in the new columns that are created. So to look at our animation here from Garrick, Aid, and Bowie, you can see what's happening here when we do the right join. This variable here, this observation, I should say, 3, gets dropped because it does not exist in Y, right? Before we dropped this 4, because that existed in Y but not in X. So when we were doing left join, it was dropped. Now we're going the opposite direction. So because 3 does not exist in the data frame that's on the right, in this case y, it's going to be dropped. For our German speakers, French speakers data joining using those two data frames, if we do that, you can see same syntax, except I've just changed left join to right join. Now you can see we're left with 9 rows. And that, as you hopefully are coming to realize, is because French speakers only has 9 rows, right? So I can scroll through here, and our data ends at District of Columbia. All of the other data that we had for other states is dropped at this point, or it's not included. Okay, let me just... thinking about this because there's actually no difference in you can see how little I actually use these other joins. Just thinking through full join. All rows and all columns for both X and Y. Yeah, the issue is that there are only 2 variables in addition to the state. So this is going to be exactly identical to doing a left join in this case. Okay, I think I get how I'm going to talk about this. Okay, let me try it. The next mutating join we're going to talk about is full join. In full join, all rows and all columns from X and Y are kept. When they're not matching values, it returns NA for the one missing. Now, here is here's the animation of what it looks like. You can see that we have 1, 2, 3, and 4. In other words, we're keeping everything here. We're not dropping 4 as we did with left join. That 4 simply gets added to the end. Let me watch it again. So 4 drops down here. And then in this variable, there's just an NA, and same thing in this variable, an NA for 3. Now with our data, when we run it, it's actually the same thing as a left join. We get the same exact result, 51 rows, and you can see we have data, we have state, and then number, and then French speakers. Now, if we had, for example, in French speakers, say we had Puerto Rico, which does not exist in the German speakers data frame. In that case, at the very end, there would be a row appended to it, and we would end up with 52 rows. So that's the idea of the full join. It's taking all rows and all columns. Okay. The last mutating join that we're going to talk about is inner join. This is going to take all rows and all columns from both X and Y, but where there are not matching values, returns NA for the one that's missing. Hold on, I need to watch this and think through it. Taking a look at our animation, you can see when these two data frames are joined, we are left with just two rows, right? Just the 1 and the 2. We keep all columns, but we only keep the rows where there are matches in both. Wait, is that right? Where they're not matching values returns NA. Yeah. Three, four. Oh man, I find these really hard to explain. So where they're not matching values returns NA for the one that's missing. All rows and all columns. Yeah, so they're not matching. So 3 does not have a match in Y. So then it's it returns NA, and similarly 4 does not have a match in X. Okay. And if you're watching and you have better ways of explaining these, please let me know, because I find these really challenging to explain for some reason. Okay, let me just let it scroll through. Let's take a look at what inner join does. As you can see, we are joining X and Y as we've done throughout. Here, though, we keep all rows and all columns, but if they're not matching values, those are dropped, or NA is returned. So for example, 3 in X does not have a match in Y, so it returns NA. 4 also does not have a match in X, so we get NA there. So we're left with these two rows. Taking a look at inner join using our French speakers and German speakers data, if we did inner join on these, we would only return rows where there are matches between them. So in other words, we'll only return rows where they share that state in common. Now, in this case, this is going to return exactly the same thing as our right join. Hold on, but I'm thinking if we had that like Puerto Rico row. Yeah. Okay. In this example, it's going to return exactly the same thing as if we had done a right join. But imagine we had a state a row for Puerto Rico in our French speakers data frame. If we did that, that would not be returned in an inner join because Puerto Rico does not have a match in X in the left data frame, which is German speakers. Okay, so that's how we would end up with a difference in our inner join. All right, give me just 1 second. thinking through this. Whoops, that is not what I wanted. Okay. All right. The next set of joins that we're going to look at are what's known as filtering joins. These joins match observations in the same ways as mutating joins, but ultimately affect the observations, not the variables. Let's work through a couple examples to think about what that means. The first filtering join we're going to talk about is semi-join. In this case, we're going to join. Hold on. The first example we'll talk about is semi-join. Semi-join will enable us to keep all rows from X where there are matching values in Y, keeping only the columns from X. Okay, taking a look at the animation, you can see what happens here where we're only left with the columns from X. Hold on, I need to go back here. Yeah. Taking a look at the animation, you can see that we're only keeping rows from Y that have matches in X, and we're only keeping the variables from X. Okay, so it's a different type of join. It's a filtering join. Using our German speakers and French speakers data frames, we could do a semi-join. And if we do it, you'll see we're going to end up with 9 rows. So in other words, we get 9 rows because we only keep matches from X, from German speakers, or we only keep states that have matches in Y. So again, there were only 9 states in the French speakers data frame, which is why we only end up with 9 after we run the semi-join. And as you can see here, we also only end up with the variable, the number variable from the German speakers 2019 data frame, excuse me. We do not end up with the French speakers variable that was in our French speakers 2019 data frame. Okay, so that's a difference. Next is anti-join. Anti-join allows us to keep all rows from X where they're not matching values in Y, keeping just columns from X. Okay, so this is kind of the opposite. Let me show you an animation. Let's take a look at the animation. Let's take a look at the animation of anti-join. So when we join X and Y, it finds matches between them. Hold on. All rows from X where they're not matching values in Y. All right, taking a look at the animation, we're going to keep all rows from X where there are not matches in Y, and we're only going to keep the variables from X. So you can see, for example, they're joined, but then the only observations that remain are ones that did not exist in y. So that 3, which existed in x, but did not exist in y, after we do the anti-join, that's the only one that remains. And if you're wondering, like, what would you use this for? I actually use this on a project where I had a list of URLs that I had previously actually posted on Twitter. And I wanted to post additional URLs on Twitter, but I needed to check to make sure I hadn't already posted them. So I did an anti-join with the new list of URLs, and I compared that to the already tweeted list of URLs. And then I did an anti-join, and then I was left with ones that I had not yet tweeted out, and that's how I knew which ones to tweet out. So that was a good use case for anti-join. Looking at our French speakers and German speakers data frames, if we do anti-join on them, you can see when we run it, we're now left with 42 rows. And 42, as you might be thinking about right now in your head, is 51. So the total number of states, plus the District of Columbia that we had in the German speakers 2019 data frame, minus the 9 that we had in the French speakers 2019 data frame. So you can see we don't have anything before Florida because the French speakers 2019 data frame had all states in the District of Columbia up through Florida. Up through alphabetically, that is. All right, so for my turn, I am going to download an Excel file, Oregon Districts and Schools.xlsx, and I'll show you how I'm going to do this. I'll show you where you'll find it, where I'll find it, and then where you'll find it. I'm going to import a new data frame called Oregon Districts and Schools from this. I'm then going to merge Oregon Districts and Schools, this data frame, into the 3rd grade math proficiency data frame so that I can see the names of schools as well as associated districts. The issue is that in my data frame, as I've been working on it so far, I only have school IDs, and it's just a numeric. It's not really meaningful. So if I want to add on school names and associated districts, I need to do this type of join. Got really itchy as I was doing that last one. Okay. I just need to get the URL for the raw data. All right. Just check one thing. Okay. All right, let's take a look at where I ended up last time. I'm going to open up my 3rd grade math proficiency data frame. I had school ID, proficiency level, number proficient, percent, and year. So now let me import the data on that has school IDs, school names, and districts, district IDs, and district names. So let me do Oregon, import Oregon, school and district data. And I'm going to download the file. So URL equals, and I'm just pasting it in there, and then dest file equals data raw slash, just copy that. Download file. Typos would get you every time. Okay, I've downloaded that. Let me just go in here and check. Great, there's that data. And again, like I did before, I'm just going to comment that out because I don't need to actually re-download the data once I've done that. So Oregon districts and schools. Let me make sure that that's the name. Yeah, Oregon districts and schools. Okay. And this is an Excel file, so I'm going to use read Excel. Path equals. I could even actually just copy it. Oops. And let me actually just open this up. I think it just has one sheet, but let me make sure. All right, so looking at my data, yeah, I have attending, district institutional ID, district, attending school institutional ID, and school. And I only have one sheet. Okay. So I have the code here. I don't need to put the sheet. I could. I'll just put it in case anything gets added. Oh, is that not the right name? Hold on one second. Let me check that. Oh. So on this file, there's just one sheet. I'll just list the name just to be safe. It's called sheet 1. Now I can open up my Oregon districts and schools data frame. All right. First thing I'm going to do, let me run clean names on that. Because it's got some funky variable names. Open it back up. All right, this is already looking better. Cool, I've got district ID, district, school ID, school. All right, so I want to join, and it's school ID is what I want to join on. So let me do this. Let me do third grade math proficiency, and I'm going to overwrite it with itself. Actually, let me do this. Let me join, make a section where I'm going to join school and district info. Okay, so I'm going to assign it to itself, and then I'm going to use left join. Because like I said, that's pretty much what I always do. So my first data frame is third grade math proficiency. My second data frame now is this Oregon districts and schools. And then I need to tell it what the variable in common is. So here it's called school ID. Here, it's actually called something different. It's called attending school institutional ID. So let me go over here. So I'm going to need to do C, and I'll do school ID, because that's on the X on our first data frame. School equals attending, what was it? Attending school institutional ID. School institutional ID. Let me run that. Okay, it's telling me problem with this, it must be present in data. Huh, I wonder if did I spell it wrong? Institutional. Oregon district. sometimes what I do is this. I'll just do, whoops, names, which will return the variable names. So let me just copy that now. That's very strange. What is going on? Left join. I think you don't actually need to put the quotes around the variable names. I don't know why I do, but I usually do. Gives me different errors, but that's so weird because it's definitely there. Let me restart my session. Just run the whole thing. Oh, sorry. I know. I'm an idiot. So I don't want to assign it to third grade math proficiency. I want to assign it to the result of the left join. So this should work. Yeah. All right. Okay. Okay. Let me go back and pretend I haven't done this. All right, let me join this Oregon districts and schools data into our third grade math proficiency. So I could just do it using a left join, and I could put third grade math proficiency, Oregon districts and schools, and I actually see a little typo here. And then I'm going to use the by equals. And in the third grade math proficiency, my variable is called school ID. And that is the same as attending school institutional ID in our Oregon districts and schools data frame. So attending school institutional ID. So let me go ahead and run that. And look, that has now returned the results, which is great. You can see now I have school ID, proficiency level, and then it's added on additional columns here that has district X, school X, etc. Okay, let me assign this now. I want third grade math proficiency to be assigned to the result of that. In other words, I basically just want to say, now, like, let's just make this the result of doing that. So if I open up third grade math proficiency now, you can see what I've got. Okay, why? Oh, it's it's like joining multiple times, which is how I'm ending up with these multiple like district. Yeah, okay, I gotta start over. Go ahead, R, you can do it. All right, now that I have my Oregon districts and schools data frame, I am ready to join this into my third grade math proficiency data frame. I've made a section here for join school and district info. So I'm going to start out by, I'm going to do a left join. So I'll do third grade math proficiency. is my first data frame. My second data frame is Oregon districts and schools. Now looking at these, let's see, third grade math proficiency. Let me do that again. Now, looking at third grade math proficiency, I've got school ID. In the Oregon districts and schools data frame, that same variable is called attending school institutional ID. So I'm going to need to keep that in mind as I join. So I'm going to do by equals, and then I'll do C, and I'll do school ID equals attending institutional, let me make sure I got it right. Or attending school institutional ID. All right, and it has joined that. And here's my results. Great. So let me now just assign this back to my third grade math proficiency data frame. So I'm going to go ahead and run this. And now when I open up third grade math proficiency, you can see I've got school ID, proficiency level, percent, number proficient, percent, year, and then I've added these additional columns here, attending district, institutional ID, district, and now I have the school name, which is going to be really helpful when I'm doing some plotting of this in the next section of the course. I'm just going to do one thing. I just want to change the order a little bit. I'd like to have school ID. No, actually, you know what? I'm going to leave this for the next lesson. Okay. All right, let me do the your turn section. All right, for your turn, you are going to download the same Oregon Districts and Schools Excel file, put it in your data raw folder, and do that using the download.file function. I want you to import this into a new data frame called Oregon Districts and Schools. And then I want you to merge the Oregon Districts and School data frame into your enrollment by race ethnicity data frame so you can see the names of your districts. Okay. Whoops. I'm just going to cheat a little bit and copy that. All right, so now, oops. All right. All right, now let me just remind myself what my data looks like. I've got district ID, race, ethnicity, number of students, percent, year. All right, so to do this, first thing, I'm just going to download the data. Here is the code, same as I used for my turn. I'm going to import Oregon Districts and Schools. Got it right here. All right. And now I'm going to make a new section. So I'm going to join district, just call it join district data. That's fine. So now I'm going to do a left join, and I'm going to join the enrollment by race ethnicity with the Oregon Districts and Schools. And let me check for enrollment by race ethnicity. I Okay, it's district ID equals, here it's called attending district institutional ID. Attending district institutional ID. I can see the results displayed down here. That looks good. Yeah, I've got district names added, school IDs. Yeah, those are not going to be actually helpful, because looking at this, in our Oregon districts and schools data frame, it's actually at the level of schools. Hold on one second. I'm actually wondering, I think I had the idea for folks just to download a separate Excel file that just has district data. Let me see that. Yeah, okay. Okay. All right, let me go back to the your term. Oh, you know what? I actually need to change that. Oregon districts. Okay, I'm gonna let this knit. All right. Oh, wait, it's still going. Hold on. All right, perfect. Now I got... All right. For your turn, I'm going to have you download a file that just contains data on Oregon districts. And I will put the URL below in the your turn section so you know exactly what to do. I want you to download this to your data raw folder. Then I want you to import a new data frame called Oregon districts from this Excel file. Then I want you to merge this data frame into your enrollment by race ethnicity data frame that you've been working with so that you can see the names of the districts. Because when you look back at it, you'll see right now you only have district ID. All right. Minimize that. Run everything. All right, here is where you left off last time. enrollment by race, ethnicity, district ID, several other variables here. First thing I asked you to do was download the data. I'm going to cheat just a little bit. That's actually me copying the code from the My Turn section where I downloaded Oregon districts and schools. Districts. So I'm just going to uncomment that. I've got the URL for the file that you are going to be working with. Let me just make sure. Yep, there it is. I can comment that now. And now I'll just do Oregon districts. So let me go ahead and run this now using Read Excel. I think that's the name of the sheet. Make sure it worked. Yeah. All right. So now I have attending district institutional ID and then district, which is the name of the district. All right. So now I want to join district data. So I'm going to do this as a left join because I think, as you probably know now, left join is my favorite. Enrollment by race, ethnicity, and then Oregon districts. And then for our by, in enrollment by race, ethnicity, it's district ID. In Oregon districts, it's attending district institutional ID. So I'll do district ID equals attending district institutional ID. Cool. I have my result here. So now I will assign this to enrollment by race, ethnicity. Let me just indent everything again. Run that. Reopen enrollment by race, ethnicity. And you can see now I have the district name added on here. Okay. Man, took me an hour and a half to record that lesson. Give me just a second to start and restart my recording. Okay. All right, I think the last little bit of this section, which actually gets us to the end, should be pretty quick. Knock on wood. All right. All right, the next thing we're going to talk about is renaming variables. I put this after the data merging section because a lot of times after you do some kind of join, you end up with some funky name variables. So let's talk about how you can rename things. Taking a look, for example, after we did a left join of our French and German speakers data, you can see we end up with state, number, which is not super descriptive here, and then French speakers. We could use the rename function, and we do it like this. You start with your data frame, then you do rename, and you put new variable name equals old variable name. So for example, and you actually don't have to put, I should make that consistent. All right, I just had new variable name, old variable name in quotes. You can put them in quotes, but you don't have to. So I want to remove that. Okay. The first way to rename variables is using the appropriately named rename function. So with this, we start with our data frame. Then as you can see here in the rename function, you want to put your new variable name first, and then you say equals old variable name. So for example, in our data, I could rename that number variable, which was not super descriptive, especially after I had done the join, to German speakers by using the rename function here. And after I run that, this is what I end up with. State German speakers, French speakers. Okay. You can also use set names. Set names is if you want to just list the names of the entire data frame of all variables. I'll use this actually in cases where it's just simpler. If I'm going to do like a bunch of renaming, I'll just use set names instead. So I could do set names, state German speakers, French speakers. And when I end up there with that, and what I end up with is this: state German speakers, French speakers. You might notice just a bit of inconsistency. I have these in quotes. You don't have to put them in quotes, but you can with rename as well. I didn't list them in quotes, but you could put them in quotes. Either way, it'll work for you. So for my turn, I'm going to use rename and or set names to give the 3rd grade math proficiency data frame some more meaningful names. Yeah, these are going to be much quicker. Okay, I'm just going to close this, restart my session, run everything. Okay. All right, as a reminder, my 3rd grade math proficiency data frame looks like this. School ID, proficiency level, number proficient, year. So I specifically want to focus on this attending district institutional ID. That's a really funky name. So I'm going to use rename, and I'm just going to call it district ID equals this here. Oh, I actually know what's happening because, wait. Yeah. What is happening is that it's now trying to join again, and it's not working because I'm overwriting it with myself, or with itself. Let me rerun it up to that point. Just thinking about how I want to handle this, because I actually have a section. The next one is to tell people to like reorganize their code so this issue does not occur. You know what? I should just show it causing an issue, actually. Okay. Let me restart this. All right, so I'm going to deal with this by doing rename and I'm going to call this district ID equals attending school institutional ID. Okay, I have an issue here. It says can't rename columns that don't exist. Now that's weird. I think what's going on here is I have actually already run this to create this third grade math proficiency. So now when I'm running it again, it's trying to overwrite it with itself. And so when I say, for example, left join school ID equals attending school institutional ID, it doesn't, the X column doesn't exist. Basically what's happening is that I'm trying to continually overwriting something, which is really not great practice. And in just a second, I'm going to actually suggest how you might get around this. To avoid this issue for now, let me just restart this. And let me just run everything up to this point. So I just have third grade math proficiency as I have created it here after I did the bind rows. Let me give this just a second to run. All right, so third grade, oops. Okay, so if I open third grade math proficiency, here's what it looks like before I've done any merging. All right, let me close that. Now if I run this, what is going on? I think what happens is it doesn't make any sense to me why it's erroring there. Let me see something. Restart this. All right, weird. Somehow there's something with that variable, but I don't really care because, yeah, I don't really care because I'm actually not going to use that variable anymore. So let me just, all right, let me all right, let me restart this one more time. Close that. All right, let me take a look at my third grade math proficiency data frame. This is actually before I have done the merging. Okay, so let me do it actually. Let me run this so I show it after done the merging. The one variable that I want to change, I call this PCT. Let me call that percent proficient. So I'm going to use rename, and I'll call this %_proficient equals PCT. So when I run that, let me take a look. Okay. I definitely got %proficient. That's good. Interestingly, though, I'm starting to get attending district institutional ID X, district X, school X, same variables, attending district institutional ID Y, district Y, school Y. Now, I'm going to actually talk about this in a second, but the reason that is happening is because I'm running this multiple times. So in other words, I did the join once and assigned it to 3rd grade math proficiency, and now I did it again when I'm using the rename. So in the next lesson, I'm actually just going to very briefly show you how you can avoid this issue. But for right now, the most important thing is that I rename this variable. All right, let me close that, do the solutions, run that, okay. All right, for your turn, I want you to use either rename or set names to give your enrollment by race ethnicity data frame more meaningful variable names. And in particular, I want you to change that PCT variable to something more descriptive for your data. All right, let's look at our data. We've got enrollment by race ethnicity here. District ID, race, ethnicity, number of students, PCT. Okay, that's the one that I'm going to change. So let me do rename. And that is I'm thinking about exactly what the PCT means. It's % of total at a particular school. So % of total, I'll make it, it's a little long, but % of total at school equals PCT. Go ahead and run that. And now I have that. And you're going to see here, we're getting that same district X, district Y issue. But for now, we've gotten this renamed. Okay. Let me stop recording so I can go on. To this. So I'm going to demonstrate how to avoid this issue, where you're kind of like running it multiple times. So I actually need to run it twice here to make sure I get that same problem. Oh wait, no, here's what I need to do. Run it down to that point and then run it again. Yeah, okay. Let's take a quick interlude here to talk about reorganizing our code so we don't end up with that issue where we're getting duplicate variables. I'm going to flip over here and look at my 3rd grade math proficiency data frame where I'm getting the .x, .y, etc. So again, what's happening is I ran this code once when it just looked like that. I ran that, and then I ran it again with the rename added on to it. And so as a result, I had 3rd grade math proficiency. It was like joining multiple times, which is how I'm ending up with this .x and .y stuff. What this leads to, generally speaking, this can lead to issues where if you are assigning, you're creating a variable in multiple places, it's often hard to know what exactly, or sorry, you're assigning, you're creating an object in multiple places. It's hard to know kind of like what state that object is in. In other words, is 3rd grade math proficiency, for example, the version that's created in these 2 lines, or is it the version that was created when we just ran it? with these 3 lines? Or is it the version that's created when we did these 4 lines, right? Like I could rerun this, say, those 2 lines, and now I have 3rd grade math proficiency, and it's back to that state. So the way we want to do this is we want to actually reorganize our code a bit so we're only creating it once. So I am going to actually add this left join. I'm going to copy this here. And actually, you know what? I'll just type it out. I want to do left join here. Now, because this is part of a pipe, I don't need to put the first data frame because it's getting passed in from the result of this bind rows, right? So I don't need to type 3rd grade math proficiency. I can just start with Oregon districts and schools. And then I can do, and I'll actually copy this because I'm lazy, by equals school ID equals attending institutional ID. Let me go ahead and run that. And now I have 3rd grade math proficiency, and you can see I've joined it here. Got my district, school, attending district, institutional ID. Cool. Now, what if I add on this rename? Let's see if this is going to cause the same types of issues. Run that. Now it doesn't, right? Like I don't end up with that district X, district Y. And the reason is because I've gone back to the beginning and creating it. And 3rd grade math proficiency always starts from the point where it's doing that bind rows. Then it's doing the left join. Then it's doing the rename. Whereas before I was doing it, I was creating it up here, but then I was kind of like recreating it down here. So now I can delete this. Okay. Let me just, I guess it is indented correctly. So, okay, I have my 3rd grade math proficiency. This looks good. There's one issue that I'm going to come up with, and that's this. Let me restart my session. Let's say I want to run this again. So I just select it all, and I'm just running the entire script file. Let's see what happens. Okay. As this was running, you're going to notice it says error in is data frame Y, object Oregon districts and schools not found. Now the reason why that's happening is if you look at the order here, this Oregon districts and schools data frame is created down here, whereas I'm actually calling it here, right? But it's giving me an error because it's saying, hey, that doesn't exist because we haven't imported it yet. So to do this, what I'm going to do is I'm going to need to just reorganize my code. Let me bring this code up here into my import data section, or actually I'll do it into my download file section. I'll put that, and then I'm going to import this data here in that import data section. Now I can go back down here. I can get rid of import Oregon school and district data. I no longer need that. Let me restart my session, select all of my code, and I'm hitting Command Enter to run it. Let's see if that works. All right, I have run this code. Let me open it up. See, I did not get that same error about Oregon districts and schools not found. Let me open this up. And yeah, this looks good. I'm going to do just a couple things. I'm going to select only the variables that I need. So I will do I don't need that attending, what was it? Attending school institutional ID. I'll drop that. Okay, I have no idea why that is can't subset columns that don't exist, but it does exist. All right, let me just try it a different way. So let me just select the variables that I want and put them in a sensical order. I'm going to select school ID, school, then district. So I'll do school ID, school, district, and then I will select number proficient through year. So I'll do number proficient through year. So now if I open that back up, I have a very nice, clean, and tidy data frame. For your turn, I want you to reorganize Try that again. For your turn, I want you to reorganize your code so that you create the enrollment by data. For your turn, I want you to reorganize your code so that you only create the enrollment by race ethnicity data frame in one place. You're going to have to do a bunch of reorganizing in the same way that I did. Let me restart my session. All right, let's reorganize this code. So basically, first thing I want to do is I want to bring up my left join here. I don't need to include enrollment by race ethnicity here because I'm using it within a pipe. That looks good. Let me run this, make sure that that runs. Still gives me the same thing. Yep. Now, again, just as with the my turn, we're going to need to move this up. So I'm going to put this into my download file section. And then I'm going to put the Oregon districts into my import data section. Go down here. Yeah, I can delete that. And just to test to make sure everything works, let me restart my session. Select all, and run it. All right, if I open this up, you can see I now have district ID, race, ethnicity, number of students, percent of total at school, year, and district. Let me actually just do one thing. Just do select, and I'll do district ID, district. And then I'm going to use the everything function. So what this does, I'm saying select district ID variable, then the district variable, then everything, which will get everything else, just to kind of reorganize. So you can see how I've got that. Great. All right, I've got one more lesson and then I'm going to call it quits for the day. And because I hear my kids behind me, I'm just going to give them a second to go upstairs and then I'll go ahead and do that. think they went upstairs. All right, the last thing we're going to do in this section is export our data. I suggested in the beginning of the section on data wrangling and analysis that getting your data into this tidy format and cleaning it generally is really best done in an R script file. Now that we've done this all in an R script file, we can just export our data and then simply use that saved data, that exported data, when we're doing anything in R Markdown in the future. And that makes it so that we no longer have to run our entire code to do all that data cleaning every time we want to, say, knit our Markdown document. There are many ways you can export your data. I'm going to show you two of the most common. The first is writing to CSV. It's going to be pretty straightforward, I think. It's basically the opposite of read_CSV. You will first list the name of the data frame. So for example, our French and German speakers 2019 data frame. And then you list the path where you want it to be saved. So if I do hold on, let me actually like explicitly writing out argument names. Whoops, that's not what I wanted. All right, let me knit this one more time. The first way we're going to export data is to a CSV. It's good, of course, if you want to share it with anyone. Anyone can open this, take a look at it, even those who are not data analysts, not working in R. So you can use the write_CSV function. You first give it the name of the data frame that you want to write to a CSV, and then the path. So I have done path equals data/French and German speakers 2019. I mentioned before that this kind of data raw folder and is common in package development. The idea also of using just a data folder to put in kind of cleaned and tidied data also comes from R package development. So I think it's a nice convention to follow for any kind of analysis that you're doing. But you don't have to, of course, put it there. You could put it wherever you want. You can also use write_RDS. RDS is a file type for working in R. Obviously, it's not good if you want to share it with someone who's not using R, but it's really helpful. And this is actually the file format that I typically save in if I want to pick something back up or, for example, load it in an R Markdown file. There's some things that are helpful by saving to RDS. Specifically, all of the variable types that you have set will show up correctly. With the CSV, they most likely will, but they may not. So saving to RDS if you're going to work again in R is the best way to go. So for my turn, I'm going to export my 3rd grade math proficiency data frame as a CSV, and then I'm going to export it as an RDS file. Okay, let me close that. Okay. All right, I want to save my 3rd grade math proficiency data frame, which I left looking like that. Let me make a new section. Just call this, I'll call it export data. You can see now I've got a really clear outline here of what happens in this file. So I will first save to CSV, write CSV, 3rd grade. I don't know why it's not autofilling. And then path equals data. Excuse me, hold on, let me do that again. All right, let me, hold on. Okay, I'm going to write this to a CSV by using write_CSV. And I want to save the 3rd grade math proficiency data frame to the path data / 3rd grade math proficiency.csv. And again, I just like to use dashes when I'm saving for file names and underscores for object names in R. Just my personal preference. You don't need to do that. Let me run that. It's giving me an error, no such file or directory. I do not have a data folder yet, so let me make one, data. And now I've got my CSV there. Let me also save this to RDS. So I'll do 3rd grade math proficiency. And same thing, except I'm going to save it as RDS. And you can see I have it here. And in the next section, you'll learn about importing RDS files, which is as simple as importing a CSV. For your turn, you are going to export your enrollment by race ethnicity data frame as an RDS file into the data directory, which you'll need to make if you have not already done so. All right, here I have my enrollment by race ethnicity data frame. Done everything up to this point. That's what it looks like. So now I'm just going to make a section, and I'll just call this export data. And I'm going to do write RDS, enrollment, whoops, I spelled that wrong, enrollment by race ethnicity, path equals data / enrollment by race ethnicity dot RDS. I didn't have to make that data folder because I had already made it. And you can see if I go in here, now I have it saved. Yep. All right, I am all done. Let's stop my recording. Just need to check one thing. All right, well, I am all done with this section of the course, and I am going to sign off for the day. Thanks to everyone who has been following along. I appreciate you. This public accountability of live streaming myself is actually really helpful for me. So I appreciate, even if you haven't commented or anything, I appreciate you following along and forcing me to get this done so I can get it out to folks. If you have any questions, please let me know. And I will actually be back tomorrow at the same time, 10 a.m. Pacific, to record some more lessons. Okay, thanks.